Welcome students. Today we are going to continue with the measures of dispersion. In our previous class we discussed about the range, and then we had a Zoom meeting whereby we discussed about the interquartile range. But now I want us to repeat on the interquartile part, and then do some kind of reminding ourselves on the range, on how can we be able to compute the range. So we said that the range, for you to get the range, is the difference between the highest data value and the lowest data value, whereby you can be given a question like this, 65, 11, 13, 23, maybe 1. And then they will ask you to compute the range from the given particular kind of data. So how can you be able to compute the range? You take the highest data value, and in this scenario, the highest data value from this data set here is 65, and then you less 1, which is the lowest data value, and then you get your answer to be 64, which is your range. So that's how you compute the range. It is very simple to compute, very simple to compute, but it's not very accurate. So most of the people do not use the range in terms of calculating the measures of dispersion. It's simple, but it does not give the accurate figure that is required by those people taking statistics. So from the range, I want us to discuss about the measures of the interquartile range, which is also a measure of dispersion. So range was number 1 measure of dispersion. Number 2 measure of dispersion in the topic of measures of dispersion is the interquartile range. The interquartile range. And how do you compute the interquartile range? The interquartile range, I told you that you should always be conversant with the formula of the median. If you can be able to remember, the formula of the median was the lower class boundary plus into bracket half n minus the cumulative frequency multiplied by the class interval divided by the frequency, whereby we say that this is the frequency of the median class, f, the f you are seeing here is the frequency of the median class, I being the class interval, L being the lower class limit, and then n being the total frequency, and this was our median. So the median formula is what we are going to use in calculating the interquartile range, but now we are going to do a little bit of changes. From the word interquartile, meaning that we are going to have quarters, and a quarter is 1/4. So what is going to change is just this part, the half n, because interquartile range is going to be given by the following formula. For you to calculate interquartile range is quartile 3 minus quartile 1. That's how you calculate the interquartile range. Quartile 3 minus quartile 1. So later on we will discover that quartile 3 is going to be given by the following formula. So you must get quartile 3 formula first, and then quartile 1 formula. When you compute the formula and substitute the equation, the answer you get in quartile 3, you are going to less quartile 1. So quartile 1 will be less from quartile 3. So this is what I mean. Quartile 3 will be given by the following formula. Q3 will be the lower class boundary of the lower class limit plus into bracket. This is now Q3, 3/4n minus cumulative frequency above quartile 3 class. Remember, this was cumulative frequency above the median class. So this is going to be cumulative frequency above quartile 3 class. So above quartile 3 class, and then you close the bracket, multiplied by the class interval, divided by the frequency. You divide by that kind of particular frequency. So that's how you calculate quartile 3. Quartile 1, Q1, let me use the upper side. So Q1 will be given by the following formula. Quartile 1 will be the same formula, so it's going to be lower class boundary plus into bracket 1/4n minus cumulative frequency above quartile 1 class. So you have the cumulative frequency above quartile 1 class. You close the bracket, you multiply by the class interval divided by the frequency of quartile 1 class. So the answer you are going to get here and the answer you are going to get here, the answer from quartile 3, if you assume that the answer that we have gotten from quartile 3 is 20, or rather maybe it is 30, the answer, let us assume that that answer is 30, and the answer that we have gotten from quartile 1 is 10. So you are going to take quartile 3, which is 30, minus quartile 1, which is 10. You get your interquartile range or interquartile deviation. So another name of interquartile range is interquartile deviation, which is going to be Q3 minus Q1, which now will give you 20. So that's how you calculate the interquartile deviation. Q3 minus Q1, you get your interquartile deviation. So maybe we are going to do some illustration and then we can be able to understand the point. But before we go there, I want to remind you quickly that the way we were getting the median class, we were taking n over 2 or half n. That's how you get the median class, half n. So this half n, which is here, is the one that is going to give us the median class. And the median class, we're going to check it in your cumulative frequency so that you can be able to see where it is going to lie. And then for you to get now quartile 3 class is going to be 3 over 4n. You just take that part so that you get that quartile 3 class. You know, you must get quartile 3 class so that now you can substitute the formula. You can know you are the lower class boundary to use. You can be able to know the cumulative frequency and other frequencies. Here the frequency of the quartile 3 class. First of all, you must identify where does quartile 3 class lie. And the quartile 3 class is going to lie under this kind of particular formula, 3 over 4n. So you use 3 over 4n, which is this, to calculate that kind of particular class. The same way is going to apply in quartile 1 class. It's going to be 1 over 4n. That's how you get Q1 class, quartile 1 class. You just use this kind of formula there, 1 over 4n, and n is our total frequency. Is our total frequency. Maybe now we are going to do an illustration so that you can understand what we are actually doing here, for you to take the point home. So the illustration will be as follows. So you have been given marks, the number of students, you have 10 to 20, 20 to 30, 30 to 40, 40 to 50, maybe 50 to 60. There you have 11, 7, 13, 1, then 5. And then now they are asking you to compute the interquartile deviation. Interquartile deviation. So how do we compute the interquartile deviation? Interquartile deviation, we have said that is going to be given by the following formula, Q3 minus Q1. So that's why we start from Q3 minus Q1. But now, remember Q3, for you to get Q3 is going to be, so your Q3 will be the lower class boundary plus 3 over 4n minus the cumulative frequency above quartile 3 class, multiplied by the class interval divided by the frequency of quartile 3 class. And then Q1, we have said is going to be given by the lower class boundary plus, into bracket, 1 over 4n minus the cumulative frequency above quartile 1 class, we close the bracket, multiplied by the class interval divided by the frequency of quartile that's how we are going to substitute the formula. So because now we have the cumulative frequency here, this number of students is going to be our F. The number of students will be our frequency. So we get the cumulative frequency. So we are going to start with the 11, and then what we will do, we add 11 plus 7, which will give you 18, and then 18 plus 13 will give you 8, and column that one. So it's going to give you that one plus 1 is going to give you 32, and then 32 plus 25 will give you 57. So you are going to have 57 here. So meaning that even the total frequency here is going to be 57. So if you add 11 plus 7 plus 13 plus 1 plus 25, will give you 57 as the answer. So what we will do then is this. We want to identify quartile degree class. So we are going to start by calculating quartile degree. So we must identify quartile degree class. And how do we identify quartile degree class? We have said that we take this element 3 over 4n. So we are going to take 3 over 4 times n. N is the total frequency, which is 57. So 3 over 4 times 57. We get the answer. Let me use the calculator. So it will be 3 over 4 times 57, which will give you 42.75. 42.75. So what we will do, the 42.75 here, we come to the cumulative frequency and we see where 42.75 is going to fall under. So 42.75 will actually fall under the cumulative frequency of 57. So you circle this one here. So this is quartile degree. So that's how you identify quartile degree class, where 42.75 is going to fall. So you have now the lower class boundary to be 50, and then you have the cumulative frequency above quartile degree class, which is going to be 32. You have the frequency of quartile, the quartile 1, quartile degree class, which is going to be 25, and then you have the class interval, which is going to be 60 minus 50, which will be actually 10. So let us substitute it. Let me put the camera for you to see it properly. So we want to substitute it below here. So we want it to substitute it below here, maybe on this far end. Remember, this is the formula of quartile degree. So the lower class limit is 50, so it's going to be 50 here. You are going to add 3 over 4n. 3 over 4n is what we have done here, which is going to be 42.75. So plus into bracket 42.75, which was 3 over 4n, and that we did substitute this far end, and then minus the cumulative frequency. We are going to raise the cumulative frequency above quartile degree class, which is this one. This is the one that is above quartile degree class, so cumulative frequency above is 32. So we raise 32, we close that bracket, and then you multiply by the class interval, which is 10, and divide by the frequency. The frequency of Q3 class, and the frequency is basically 25. So this is your frequency, which is 25. So we start, we apply the rule of body mass, that we always start with what is inside the bracket. So we are going to have 42.75 minus 32. So 42.75 answer minus 32, you are going to get 10.75. So 10, we have 10.75 over 25 times 10. So divided by 25 times be 4.3. So plus 50. So this 50 which is here. So if you add that to 50, you are going to get 54.3. So you have your answer to be 54.3. So that is your Q3 class, 54.3, and that's how you get it. The 54.3 as illustrated there. So 54.3, yeah, that will be your answer. So let me adjust the camera for you to see it. This is your 54.3. You start solving the ones that are inside the bracket first, and then you divide by the 25, multiplied by 10, you get the answer here. You add the 50 here, you get 54.3 as your Q3. So this is now quartile 3. So that's how you get the quartile 3. Let us get quartile 1. So quartile 1, we will use this particular formula here. The lower class boundary, we must identify it first. And it's going to be identified by just taking this element here, 1/4n. 1/4 times 57. N is the total frequency. So 1/4 times 57 from our calculator will be 1/4 multiplied by 57, which is going to give you 14. It will give you 14.25. So this 14.25, we come to the table here. Let me adjust the camera, and then we identify where 14.25 will fall. So come to the cumulative frequency here, and then we check this 14.25, where will it fall under. 14.25 is going to fall under the cumulative frequency of 18. So you circle this particular part as your Q1. So that is your Q1, the Q1 class. So you have identified quartile 1 class. So if now you have identified quartile 1 class, you can be able to solve it. Maybe you can solve it at this far end here. Let us just solve it here. And be able to solve it there. The lower class boundary, quartile 1 class, we start with the lower class boundary, and the lower class boundary is 20. So you write your 20 here, plus into bracket 1/4n. This 1/4n is what we have substituted here, which is 14.25. It will be 14.25 minus the cumulative frequency, minus the cumulative frequency above the quartile 1 class. So cumulative frequency above quartile 1 class is 11. So minus 11, we close the bracket, multiplied by the class interval. So the class interval is basically taking the upper limit minus the lower limit, which is 30 minus 20, which is 10. So you multiply by 10 divided by the frequency. You divide by the frequency of quartile 1 class. And the frequency of quartile 1 class is this F. Remember, number of students was the frequency, which is going to be 7. So this is the frequency of quartile 1 class. So divided by 7. That way. So what you just take your calculator and then start with the bracket as per the rule of body mass. So it will be 14.25 minus 11. So 14.25 minus 11, you will get the answer to be 3.25. So the answer is going to be 3.25, and then write 3.25 over 7 times 10. So this 10 here. So divided by 7. And then you multiply by 10. So the answer will be 4.64. So you add plus your 20 here. The 20 which is here. So if you add plus 20, you will get 24.64. 24.64 as your Q1. So that's how you get Q1. So now, having done that, we can now be able to calculate the interquartile range. So we have our quartile 1 to be 24.64, our quartile 3 to be 54.3. So let me put it somewhere here. Yes, now you can be able to see that we have our Q1 to be 24.64. We have our Q3 to be 54.3. So our interquartile range now, interquartile range or interquartile deviation, interquartile range stroke deviation, interquartile range stroke deviation will be as follows. You take Q3, which is 54.5, 54.3 minus Q1, which is 24.64, 24.64. Then you can use your calculator so that you get the answer correctly. So it will be 54.3 minus 24.64. Your answer will be 29.66. 29.66. So that's how you get the interquartile range or interquartile deviation. So that's how we compute the interquartile range or the interquartile deviation. So maybe I may give you a question. Let me give you a question so that you can calculate that one and submit your answers. A similar question. So the question will be as follows. You are going to be given the marks here. So that is the illustration that I'll keep on using. Maybe let us change a little bit. We can even use wedges. And then we have number of employees. Wedges of the number of employees here. So your number of employees will be a frequency. It's trying to be a frequency. So we are going to have 0 to 10, 10 to 20, 20 to 30, 30 to 40, then 40 to 50, 50 to 60. So here you are going to have 1, maybe 7, 13, 3, 17, 39. So compute, we're going to compute the interquartile range. Analyze the equation. Compute from the given equation. So from this kind of particular equation, you compute the interquartile range stroke, sometimes it's called interquartile deviation. Interquartile deviation. So compute that kind of particular equation and then you can submit your answer. So thank you.